Hello, everyone. Thank you for joining us today. My name is Greg Thiessen. I'm the owner of Synergetic Engineering and Manufacturing Services, as well as XMD Expert Mold Designer Software. XMD is 31 years old this year. It started way back in 1988. It has always been built on the Key Creator platform, which was previously CAD Key. Today, you will see how fast and easy mold designing can be, as enjoyed by all current XMD users. Sean Demers, an XMD application specialist, will walk you through some of the key intelligent automation tools that we have created to make this possible. Sean, how about we get this started?
Welcome everyone to XMD demo for XMD version 2019. We're going to get into several functions that XMD does. We're going to kind of go in and kind of show you what it's like when you've already kind of modeled up your parting line, and then from there you're going to build your mold base around it. Okay? You're going to see some really cool features on how XMD takes care of building the mold base around that, doing all your ejector plates, retainer plates, and putting in a lot of the common components automatically right from get-go. A lot of things are very configurable to set up to your standards. So if you see something that you like, a different style of guide pin or anything like that, that's all completely configurable. It can be put in automatically that way or modified to those just with a single click. So very, very easy to do a lot of different things in this software. I think you're going to really enjoy this demo. All right, so we're going to start off by creating a new file. So we're going to go ahead and we're going to give this a job number. So let's give it job number 1212 and a file name 1212. And so our job number is going to be 1212 based on that. You could choose your own config file, which you can create completely on your own, or you can use the one that's built in. It's up to you. You can start with the one that's built in as well and build up on that. Okay. Part information in here. So this will help populate the title block if you are using the 2D drawings in any way, shape, or form. You can put in what your wall stock is. You can put in what your shrink value is, what press this might be going in. So it's up to you what you want to put in those particular items. It just populates the title block. Okay. As you can see already, XMD has kind of analyzed this core and cavity block that I have sitting in this file. And what it's done is said, okay, well, here's a good size set of clamp plates. Here's a good size set of rails. And what we do is we basically, over the years, 30 plus years that this product has been developed, we've built in these industry best practices based on customer feedback. And that's where a lot of these values come from. Drop-down menus if you want to change the material types. We're going to go ahead and just leave everything as what XMD is suggesting so that you can kind of see how that works. So we're going to go ahead and say OK. And so what you're going to see is XMD is going to look at this core block and this cavity block, and it's going to populate it with the rails, the ejector plate, the retainer plate, top clamp plate, bottom clamp plate. It's going to put in all your ejector guides, return pins, guide pins, and what's really cool is you're going to see the guide pins will already be at the right levels and everything. So XMD understands the parting line and everything else, and it builds accordingly. So as you can see, your guide pins are completely done with bushings. In this case, we are holding bushings in with retainer rings, so that's all automated as well if you wish. Long screws, short screws, you see are complete. All your lift holes are put in every plate, and a lot of this stuff is very configurable on what type of components you want to utilize as well. All right, we have a lot of single-click commands, so I want you to kind of be paying close attention as you're watching this, how long it takes you in the product that you currently design in to do the same exact thing. Okay? You're going to see when I put a component in, a lot of things happen all at once. For example, the material is always being generated automatically, so we're going to go ahead and just use the built-in material list. So go down here. Okay, so this is the material list template that's built into XMD when you receive XMD. Very easy to manipulate this one to suit whatever your needs are, create a full new one however you want. But you can see everything that's populated currently in this design is shown in this material list already. Okay, so material list is 100% automatic. Okay, so as we build this job, you're going to see things get added to that material list for us. Okay. So as we do a lot of single-click operations, like putting in ejector pins, for example, you're going to notice all the holes are complete all at once, the ream is complete at once, the material list is applied. So everything happens very, very fast, very rapidly. Okay, so what we're going to do now is we're going to go ahead and we're going to just show you some of the cool little functions. remember, XMD is very specific to mold design, so we have a lot of commands in there based on that. XMD understands a screw is a screw, not just another solid, okay? And it understands certain types of screws are for very specific purposes. So if I click to modify size on one of our long screws in our rails, I can do things like change the mount pattern. So I want to change to a double mount pattern. Now, there's a short screw for every single long screw, okay? And of course, I can switch back if I want to. If I change my mind that I want to go back to a single mount pattern, I can do that, and it changes it as well. So these little tiny things that we have in the product that makes things much, much faster for you for manipulation from job to job. Now, just so you know, once again, in the configuration tool, you can actually configure what the longest screw allowed is. So once it exceeds that screw length, it'll automatically switch to the double mount pattern for you. Okay. All the different types of stop buttons we can put in and different ways of implementing a lot of components. So for example, as you can see, the pushing for the guide pin is currently with the flange and the retainer plate. That's really good practice because you're going to always machine from that direction of the retainer plate, but not necessarily always machining from the top of the ejector plate. So it's a reduced setup in some cases. Now, but let's just say you do want it the other way around. You can go ahead and say switch plate. That's it. Just by clicking on switch plate and saying okay, it switches. Right? And that's all four of them. Right? All four have been switched automatically. Okay. So, you know, once again, just very easy, simple, single click operations. Okay. Sizes and stuff, once again, utilizing industry best practices. So the sizes are generally very good, and you will find it would be extremely rare that you even need to manipulate those sizes. Okay? What we are going to do, though, is manipulate one just to kind of show you how easy it is. So if I want to change that ejector guide to, let's just go to 1.5, just so it's very drastic. I'm going to say all plate, we're going to go ahead and change it. You'll see it's much bigger. Okay? So if we want to go back to the 1 inch, we can just click it. So if you want to like visually see the difference, it's just quick and easy to do, right? And in that time, the material has changed to the bigger one, that changed back to the smaller one. It knows what to do. Okay, so what we're going to do is we're going to go ahead and kind of get started on adding some water to this job. Okay? So what we want to do is add some water to the core block for starters. So what we're going to do is we're going to move these lift holes just a little bit. Okay, so as you can see, we can move them up and down, and I can move them all together. I can drag the arrow, as you can see, or I can click on the arrow and type in a value. Okay, so however you wish to do it, it's up to you. Okay, so just kind of show you. You see that all four of them move together. Okay, and we'll show you some other cool move commands that we have as well. We do a lot of things in quadrant based and stuff. Okay, so we're going to go ahead. We're going to add some water. So we're going to use the auto through water function. And what that does is I click on the plate that I wish to put the water in this case the core block, and I can choose the distance I want my water to be from part and parting line, which is I'm going to leave it at the 3/4 that it's defaulting to, and 3 inches between water lines. Okay, and then we want it to follow any contours in the parting line. This parting line is relatively flat, but you will see there's a little change here, and it does know to kind of tweak based on that. Okay, now what I could have done is I could have had my settings turned to actually put Jiffy plugs automatically on there, but we want to kind of show you how that works. So we're going to go ahead and kind of add them manually. So this is how manual it gets in XMD. If I want to add that, what I can do is I can go ahead and say I want to add a connector, which in this case is going to be a Jiffy plug, and I want a counter bore, and I want all of the same water lines to be affected. Okay? I'm going to go ahead and say OK. And as you can see, I have it set to synced ends, which means both ends of the water line will be affected by that. If I set different ends, then only the side that I picked would get modified. Go ahead and say OK, and that's it. Jiffy plugs are added, counter bores are in. Okay, so it's very, very easy, as you can see, to do that. Turn off my part data just so you can kind of see the core block. Very cool. All right, so we're going to do a quick switch over to the 2D drawings just to kind of show you that as we're working, the 2D drawings are being developed. Okay, so that's all being taken care of simultaneously. So whether you do or do not use 2D anymore, they are there and they're available if you do it for any reason, have a need for them. One thing that's really cool about them is we can make changes in them. So I'm going to say by group, and I'm going to move, as you can see, because I picked by group, it picks 4 pillar supports that are symmetrically opposite about each other. And I'm just going to move them super close together. And just the reason for that is I want to be very drastic so that you can see the difference. So this is done in 2D, but now when I switch over to my 3D, it's updated as well. Okay, and now vice versa, right? I can go ahead, grab these, say by group, and just move them out just a little bit further. Okay, pretty cool. So go back to my 2D drawings. As you can see, it's all up to date. I just wanted you to kind of see that 2D drawings are available. That can be a very useful tool in 2D when you have really complicated water, because you can quickly cut a section where you want a water line to be. You can go in that section and sketch that water in very quickly. So very, very cool feature. All right, so we're going to go ahead and go back to our core block, and we're going to kind of wrap up this water a little bit. What we want to do is we do want to go ahead and add some baffles. So I'm going to set my snap. By setting my snap, that'll help keep everything nominal, because I'm just going to basically just kind of place these by eye. And we're going to go ahead and we're going to add a water baffle. And we're going to just go ahead and say, okay, we're just going to start clicking. So I'm just kind of following completely horizontal based on my snap. And this is what's really cool, is when you go and you take a look at these baffles, the lengths are 100% automatically taken care of. So think about it. Single click, put it in position, automatically centered it to the water line. It knows to snap to the water line automatically. And then the length is completely 100% figured out for me, and the material is up to date accordingly. Okay? And at the same time, you have 2D drawings. So same thing. If I go to 2D drawings, you can see the baffles are there. So a lot of things are happening just as we're placing and doing that one single click. Okay. All right, so what we want to do now is I want to mirror these baffles over. So when I go to mirror these baffles over, which you're going to like, I'm just going to window around them. And I'm going to mirror it about this line that I drew in real quick at 0. Okay, right? So even though I mirror copied them over, XMD still knows to make sure we're not crashing into anything. So you can see underneath this insert pocket, those baffles are really short, and that's because it knows stay 3/4 of an inch away to that pocket. Okay, so now the value, of course, 3/4 inch is based on my configuration file. If you do smaller work or anything like that, you can obviously reduce that value to what works for you, but we can also modify on the fly. So what we're going to do first, we're going to take these two baffles, right? So I'm going to window around them. I'm going to say by single, because I don't want it to grab all 4. I'm going to go ahead and just move this here, right? And we'll move this one as well. Okay. All right. So what you can see is they've moved and it made them a little bit taller, okay? But they still didn't go to the height we want. The reason being is that 3/4 inch value that I have it configured for, right? So what it's seeing is the sidewall of this baffle to the sidewall of the insert is just over 1/2 inch, right? Right here, 5/16. So because of that, it's not going any taller because it's staying that 3/4 inch away to that pocket. But what we can do is we go ahead and click on this, and we can reduce the sidewall only, and I'm just going to say 450 in this case. Okay? We're going to say select. I'm going to pick this, and I'll say OK. Right? That way I kind of selected both of them and made them both work. And as you can see, height is good. So I'm never, ever calculating my actual baffle heights. I'm just telling it how far I'm OK with it to being from certain features. Okay? So when you get close to these pockets and stuff, you can put in whatever you need to value-wise to make it work. You need to get up inside a tower or anything like that, but I don't want to be any closer than a couple hundred thou away from the sidewalls. You can tell it that. All right, so what we're going to do now is we just want to go ahead and add some custom features. So I have a vent insert in here, modeled up, that we want to make as part of our design. Okay? So as you can see, we have this insert, and that's going in that pocket that we just did the baffles around, okay? But right now, it's just kind of sitting in my design, not really being looked at all in any way by XMD. It's just kind of a solid that's on a dumb level, waiting for me to do something with it, okay? So as you can see, there's nothing about a vent insert in here at all. You can see all the other stuff that we've added, like the Jiffy plugs and stuff is in there. The baffles are all in there, okay? So what we're going to do, though, is we're going to go ahead and tell XMD to utilize this solid as an insert, okay? So we're going to go ahead and we're going to say, okay, it belongs on the moving side. We're going to say plate, create, generic. And what you do is you pick on the solid, and as you can see, automatically, XMD is able to calculate the sizes, okay? What's really cool, because we are direct modeling based and we don't care about your history or parametric values of any of your products, any of your solids, you can give us a solid from any software package. You could do it here directly in, or it can come from any other software package, and you can give us the file without translating it. We can bring most major CAD system files in direct, so we don't even need a step or a parasol to do it, although we can import those as well. And I could bring that solid in and do the exact same thing I just did now and it would calculate all the sizes and everything automatically for you. So we're very, very flexible in that. We're not tied down in any way of solids being created directly in here. They could be created by another user in the same software somewhere else, or by a whole different software. We don't care which one. Okay, so as you can see, added to our design navigator here is the vent insert. Okay, so as you might have noticed, this design navigator allows you to not only navigate around your design, but make modifications to your design as well, right? So by clicking on moving side, saying play create, it made it a core half component, or a moving side component. All right, so we have our vent insert now. And obviously, as you can see, a core block. Now watch this. I go to my 2D drawings, and right here, I can highlight that vent insert. Okay, so we do things very differently as far as how we render our components and stuff. It's not just a picture of your solid. It's a working component that works, a working tool that goes with your solid. Okay. All right, so what we're going to do is go back over here to the vent inserts, and what we want to do is go ahead and add a screw to this. So this is what's really cool. Is, once again, we minimize clicks for every single command we do. So let's say I want to add a 1/4 inch screw, and I want to go, in this case, I'm going to go from the front, okay? Okay, I want to go from the front, and what we're going to do is go ahead and place that screw, so here, okay? So let's just say I'm happy with it. I'm happy with the size, everything else. We're going to go ahead and say, okay, I'm going to place the second one and say right here. Okay. So obviously, I'm going to place them to avoid water. So there's your screws. So what's really cool, if you take a look, right, you have your core block. There's your tapped hole, right? Okay, your tapped hole is in there. And switch over here. Here's your vent insert. Okay. So the holes, which hole for that screw goes in whichever plate is automatically defined. Okay, so automatically it knows tapped hole in the core block, and it knew that the clearance hole needed to be in the insert. You'll also notice some color coding for those holes. Okay, so once again, you can configure those colors to whatever you want, or use the built-in colors. So you just utilizing RGB values, you can say I want my NC tapped holes a certain color, metric tapped holes another color. So for example, if I change this screw to a metric screw, so let's change it to an M6, let's say, and I'll just go ahead and change both of them, right? You see how the hole color changes, right? Well, that's because the configuration that I have for my holes is to use that color if it's a metric tapped hole, right? And then, of course, clearance holes and your critical reamed holes and things like that all can have their own colors. This will allow you to be able to utilize feature recognition tools in your CNC machines on your floor much, much more efficiently. And because everything's working off one central config file, if you have 10 different designers doing 10 different things, your feature recognition on your shop floor isn't going to work really well. But because everybody's working off the same config file, all your holes and stuff will be exactly identical every time they go to the shop floor, speeding up your manufacturing. Okay, so a couple things that we try to do on our side is we try to help you get things to the floor quicker, which allows you to get manufacturing quicker, but we also help make the files that get to your shop floor much better and more efficient for your manufacturing to utilize them. Once again, saving over time and allowing you to bring more capacity through your facility. Okay, so I'm going to go ahead and just switch these back to an inch. And as you can see, fine, so you could actually do an inch fine or a metric fine and make those their own colors if you wanted as well. So we're going to go ahead and switch it back to a 1/4 inch. Okay, and then you'll see those colors change again. Okay, so once again, we can do a lot of other things too for manipulation. So what I want to do is I'm going to manipulate this screw. I would change my mind. I don't want to, like, you know, frost plug it from molding face or anything like that. I change my mind. I want to switch them around the other way. So I'm going to say select the other screw as well, because I want both of those screws to happen. I'm going to say redefine lines. So basically I'm telling you to start the screw at the back of the core block now and start the thread at the bottom of the insert, right? And it flips them around, resizes them accordingly, and a holes switch. Tapped holes now in the insert, and the clearance holes now in the core block. Okay, so really easy. You know, your ability to try something out and then try something else and do different scenarios really quickly really allows you to make the perfect mold design much, much easier. Okay, you know, we have meetings with customers all the time, and we'll be able to like make changes on the fly right in the meetings instead of having to wait and do the changes after. So our customers can see us, move ejector pins around, switch water locations, tip them, and modify bubbler depths and things like that. So there's a lot of things you can do very, very automatic. Okay, so we're going to go ahead now. What we want to do is we want to add some ejection to this. So we're going to go ahead and we're going to go into our ejector pins. And just quickly, just to kind of show you too, built in, you do have your standard ejector pins, step pins, return pins, screw puller pins, ejector sleeves, and more of like a custom core pin that you place at any angle you want, things like that. So we're going to go ahead and put in some ejector pins. Okay, materials, several material options, and then of course all your vendors, inch and metric. Okay, D-locked or not D-locked, all that kind of stuff. So I'm going to kind of show you. I'm going to put these in D-locked, and then I'll kind of show you how easy it is to change it back and forth. We're just leave everything default to 1/2 inch ejector pins and stuff, and we'll go ahead and just place some pins. So I'm going to place these extremely randomly, just because I really want you to kind of see how easy it is to place them and what cool things happen. I'm also going to put one through this water line on purpose, and you'll see later on down the road why I did that. Okay, so here's our ejector pin. What's really cool is XMD understood what to do going through that insert, right? So you can see the core block has the clearance, right? You go to the vent insert, clearance, and the ream. So the ream is 100% calculated for us. Once again, configurable to the length of ream you want. But by default, I believe we do 1 inch ream. D-locked, so all the holes are done in the retainer plate automatically, right? So I've changed my mind, I don't want D-locked. I can turn that off. And I can say all in plate so that they all change, or I can change just one if I want. So really easy to switch back and forth between the D-locked and the not D-locked, and the holes are all updated and everything. Once again, material list is done. All this stuff's being all updated, 2D drawings, your 3D, your material list, everything 100% done and color-coded the way you want it as well, all at the same time. Okay, so we've got that in there. Overall, liking what I see. Pretty good design. Now we go in and our customer is wanting to have a little meeting, right? Let's take a look at the job. We have a part change coming. I'd like to see where you guys are at. So we go in, we have our meeting with the customer. We're pretty happy with mostly everything, but we have a new part and we want to change this part pretty drastically. It's no longer going to be flat like this. We need more volume or something, and it's going to have this big hump instead. So what we're going to do basically is we're going to obviously remodel our core and cavity blocks, no different than what you would do with any other software, except for the fact that, once again, because we don't care about any parametrics or history-based components of your files, we can bring in that data and right away start unstitching faces and restitching or rebuilding trim sheets or whatever we need to do, depending on what the changes are. So as you can see, this is no longer flat. This now goes down the center. Instead of going straight across flat, we now have all this contour here. Okay, and then of course the same thing is true. Obviously, we have a cavity block that matches that. Okay, so what we're going to do, and this is going to kind of show you, this is a really cool feature. If somebody else was to model it for me, I could bring in their step file, Parasolid file, or any other CAD system file directly in. And what I do is just tell XMD to look at this new solid, replace the existing solids. So what we're going to do is we're going to highlight with our control keys, click on cavity and core block, right click on it, and say plate swap, right? So when we say plate swap, we now pick the cavity block, right? And then we're gonna pick the core block, right? And what it's gonna do is it's gonna look at that new solids, it's gonna update the material list, gonna update the 2D drawings, but there's also some other cool things that get updated as well, right? So we're gonna go ahead and turn this on. As you can see, all the ejector pins and all the baffles, 100% up to date, right? And we can see, obviously, we're gonna have some pins we're going to have to move and stuff like that. But once again, it's so easy in XMD to do this kind of stuff, right? So we see that those pins are an issue because we're getting kind of feather edges on them. So we can move them if we want. And this is it. It's just like that to move them, right? And it's picking the 4 that are equally spaced here, right? As you can see. So if I don't want those, I can unclick them so that they don't, right? I'm going to go ahead and click that. And there you go. As you can see, those are now much better, right? We're just kind of catching that rat a little bit, which is fine. And then we're going to go ahead and we're going to click on here and say, okay, let's select this other one as well. And we're going to go ahead and make that D-locked because we are catching that rat a little bit, okay? And then maybe we don't like that these other ones are kind of hitting this feature, we just delete them. So it's really easy to add, delete, move, modify, copy existing ejector pins, and all this stuff. So very, very quick, very fast. All right. Okay, so we've gone ahead, we've put in this new file, this new part that the customer wants, and now, you know, we're already up to date. Everything's up to date. Our water up to date, our ejector pins are up to date, things like that. So what we want to do now is go ahead and add some water, right? So we have some really cool cooling function capabilities as well. So once again, we can go ahead and use the auto through water again if we wanted to, and it would follow this shape, okay? Which is obviously really cool. So let's go ahead and do that just so you can kind of see how it works when there's a little more contour. So yeah, once again, we'll just leave everything default, but you can tell it how close you want to be to a cold screw, right? So let's just say we're okay with as close as 1/4 inch away. Doesn't mean it's going to be a 1/4 inch away. It'll just never be closer than that amount, okay? Whether it's closer or further or not just depends on the spacing. As you can see, you know, our water's spaced quite well. It's pretty good. We can obviously add. So like we're not locked into any kind of pattern or anything. I can copy this down. The only reason why it didn't go down is because in here we're a little bit closer than the values that are requested. So, right. So that's kind of, you know, just another showing of how that function works. So let's go ahead. We're just going to delete those though, because I really want to get into kind of something a little bit different with this. What we're going to do now is we're going to create a pretty major change to the overall job. Actually, let's do a lifter first. So let's go in here. We do have a lifter function that's quite cool. So we're going to go ahead and we're going to go ahead and do that. Okay, so lifter function. Let's go ahead and add a lifter. The undercut amount. So there's a couple ways you can do it. You can measure it and type in the value. What I like to do is just put a dimension on there. Once again, as you can see, I'm doing this in 2D just to kind of show you how it works. So it's really cool if you got lifters on all kinds of crazy angles, just cut a section through it. Go into the 2D and do it. Much easier than working with all the angles and different views and stuff like that. So we're going to go ahead. We're going to click on the dimension. And automatically it's figured out what my rod angle needs to be and everything to achieve my configured minimum clearance. Okay, so my minimum clearance is set to 1/4 inch. So it's gone to the next rod angle that is necessary to reach that 1/4 inch value. Okay, I can modify that rod angle, so I can say I want 9 degrees, and it'll highlight yellow and let me know, well, you're only 178 thou, but maybe in this case it's okay because the part is shrinking away from the lifter anyways, so we're actually going to gain another whatever because of this part shrinkage. So you do have some flexibility there. You can even go down to say 1 degree, and it doesn't clear, and it's letting you know you don't clear by negative 0.147. So maybe that is an intended scenario because of some part features in the way of the lifter or something, and you're letting the robot do the rest. We give you that capability to do that. But we'll go back to our 11 degrees, right? And we're going to go ahead and populate this job with this lifter. So we're going to go ahead. So our bottom of our lifter head is somewhere around there, and the angle of the rod. And then we let it run. So what it's going to do now is it's going to build me in like a mock lifter head, so I have something to kind of start from modeling my lifter. And then it's, as you can see, lifter rod, bushings, all the lifter carriages, things like that are all populated. Even the clearasoles for accessing the screw in the ejector plate and in the bottom clamp plate have all been put in. Okay? And you can see it's been added up here to my design navigator automatically too. If I switch over to that, there it is in 3D, just so you can kind of see it. Okay? So yeah, we have a lot of cool things going on here. And now let's go back for another meeting with the customer and see if they're happy with it. The customer has look at it. Yeah, this looks pretty good, but I would like to go with like maybe some modifications on steel and different things like that. So let's just say on the core side, what we want to do is we want to increase the ejector stroke to reduce the lifter rod angle, right? And on top of that, we want to change on the cavity side, we want to get rid of the cold screw and switch to a 2-drop manifold system. Okay? So what we can do is we can go ahead and even this far into the design phase, we can still make those changes. So we're going to go to our part line editor, right? Because I'm going to also add 2 inches to the back of the core block, right? So just to kind of make things a little trickier. So I'm going to add 2 inches to the core block. Dimensions are frozen, so that this way you don't accidentally make a change. So I just unfroze that dimension, and then I'll go ahead and add my 2 inches. Accept that. Now what we're going to do is we're going to add a manifold spacer plate to this, and we'll just leave the value at default to 2. But you can type in a value if you want to increase the thickness or anything. So we're going to add that manifold spacer plate. And then our ejector stroke, the customer wants you to use a 5-inch ejector stroke. That, maybe gets really close to maxing out their ejector stroke on the press, and they like to just use the most and reduce the rod angle. That's perfectly fine. So what we've done, we've added 2 inches to the back of the core block. We've added a manifold spacer plate on the cavity side, and we've increased our ejector stroke, so our rail heights obviously get taller. And we're going to go ahead and say okay and let it run. So what it's going to do is going to increase the rail heights. Obviously push the clamp plate down, ejector plate, retainer plate need to go down. The ejector guides have to get longer. The lifter rod has to get longer, and the rod angle changed, and all the feet and stuff modified accordingly. Pillar supports get longer, ejector pins get longer, baffle blades have to get longer because we've increased the thickness of our core block by 2 inches. All the material list has to be up to date. All the lift holes and stuff, all that stuff has to shift. Long screws get longer. Return pins get longer. Like, I couldn't even name everything that had to happen quicker than when it actually made the changes. All the material list has to be up to date to suit. Manifold spacer plates added. The way that is mounted has to be modified, and the sprue bushing has to be eliminated, because now that I've got a manifold spacer plate, it's obvious I'm going to a hot half, to a manifold system. Okay. All right, so let's go ahead and do some more work on this job. So one thing I'd really like to do is obviously add some water on the cavity side. I also want to add that manifold system, right? So I don't have a manifold system yet. I don't have a design from the vendor yet, because I still need to kind of supply that information to the vendor. And so what do? We usually drop in some kind of mocked in solids and stuff like that, and then we feed that stuff to whoever the vendor is going to be, and then we wait for a design from them, things like that. Well, we solve that riddle as well, because one thing you really want to do is make sure that you're getting that information to your manifold supplier as quick as possible. One thing that our customers always run into is waiting for a manifold system to come, and because they're done their design. They're as far as they can go on their design, because we move so fast in XMD. We're done the design as far as we can go, and we're waiting on that manifold system. So what you really want to do is get that system ordered as quickly as possible. Okay? So the new stuff that came in had flats and everything for the 2-drop, and there's still that flat for the cold screw in the middle there, which we really don't want. So once again, just to show you the power of direct modeling, I'm going to turn on the cavity in the core block, right? And what I'm going to do is I'm just going to tell that feature in the cavity and the core simultaneously by windowing around it to go away, okay? Right? And once again, it doesn't matter who created that data. It could be created here in this file. It could be created by another XMD user on a different system, or it could be created on a completely different CAD package. That would work just like that. Okay, so we're going to go ahead and we're going to add a manifold system to this. So we're going to go up here to stationary side, plate create, and last time we used generic when we did the vent insert. This time we're going to use the hot runner system. Okay. All right, and we get a cool little function here for the hot runner system. Okay. So what we want to do, obviously, is we're going to do a kind of custom pattern. We're going to have 2 drops, right? And we want to select our location for those drops. Okay. So obviously the center of this flat. And obviously, if you don't have a flat on the part or anything like that, you can put a point in your file, however you want to do it to locate it. Right, and we're going to click on these 3 dots here and pick this location. And there's my 2 locations for my drops. And we just go ahead and say OK. And it creates a mocked-in manifold system for me, puts it in my design navigator, adds it to my material list. And then when you get the final design from your supplier, you can swap that in. Okay. All right, so now that gives us something now that we can work with for our water, right? Because we want to get our water going on the cavity side. Okay. So we're going to go ahead and do that. So just want to kind of quickly show you how this works, so that you can see some other ways to add water. Okay. So we're going to modify our snap to 1/4 inch and make our grid match that. And then I like to turn on my grid as well. Right? That way I can see it. That just gives me a little more flexibility with when I'm working on this stuff. Okay, so we're going to go ahead and turn on the cavity block. You can see it's even got those holes for those mocked-in bores, just so you kind of know what you're doing when you're working around it all. And we're going to go ahead and start creating some what we call smart water. So smart water is, well, just that. It's very, very intelligent. It does some really cool things. So we're going to go ahead. We're going to drop a water line here. We're going to do another water line here. Okay, I'm going to switch to this side. I'm going to put a water line here, water line here. I'm going to switch views again. This is really cool stuff. When I switch back over, you can see done, right? The water circuit trimmed itself. It knew what to do. So when I went from the back and I put my water line, it knew to stop. Once again, pre-configured amount that I have is 3/4 inch, all based on the size of tooling you do. If you do smaller tooling, you might want a closer distance, things like that. And so it stopped at that distance. And then when I created my lines from the sides, it knew to stop at the proper water line to create a circuit, right? So it's really intelligent. Of course, from there, I can copy this as well, right? So I can window around this entire circuit, and I can copy it over however much I want, right? So in this case, I'm just going to kind of copy it over just by eye. The 1 3/4 inch, that looks pretty good, right? Maybe I'll go, yeah, that's good. We're wrong with that. Okay, and then, you know, same thing. If I want to take that, now, what if I want to take both those circuits and move them over? Maybe go a little closer to the drop or something like that. I can window around both of them, and I can drag them both over, right? So there's a lot of flexibility on moving everything around however you want. And because I've got my snap, it's keeping everything nice nominal numbers, just kind of automatically, right? So now what we're going to do is we're going to kind of complete the circuit a little bit by adding a line from here, right? So I'm going to put this line here, and what's cool is you'll notice this is drilling through that lock. So when I place that water line, right, a couple things happen. One, it knew where to trim to. Second, it puts a spot face and everything because it sees that there's contour. It sees that this is not, it's planar, but it's not square. It's not perpendicular to my water line. So it puts the spot face in automatically. Those spot faces are configurable. So one thing that we've seen in the past, a lot of designers don't fully understand, is that when you're putting this up on a gun drill, that diameter of your spot face has to be a certain diameter for the collar of the gun drill to seal off properly on the side of the block so you don't have oil shooting everywhere. And so a lot of times designers, because of space, they make the spot face too small, and then that doesn't work, and then the gun drill operator has to open that up bigger, and that ends up being an unexpected condition maybe in the steel and no longer matches the designs, things like that. So we allow you to have that configured properly so that automatically it's being done properly no matter which designer in your facility is placing these water lines. Right? So once again, we're helping to eliminate mistakes and improve quality. All right, and consistency across the board. So we're going to go ahead, we're going to add a counter word, a jiffy to this, and say select to also grab this other water line and say okay, and that's it, right? So just like that, you can create your circuits. It's very easy, right? As you can see, it's extremely easy, right? So we've gone ahead, we've put the water in, we've created all these nice little features, we've added a lot of cool things in the job with water, ejection, things like that. Lifter, and what we want to do is model that lifter head now, right? So just to kind of show you some cool modeling capabilities, we're going to go ahead and pull up this here. We're going to pull up the core block, right? So we have that little undercut there that we need to deal with, and as you can see, the part, one other thing that you have quick access to is shutting off transparency. So you see, I can turn off transparency of the core block real quick. And you can see we have everything colored based on part seal off clearance, right? So very easy to do when you're modeling in XMD to do this. Once again, makes things very easy for your shop floor. They can create macros based on these RGB values, and they can really speed up things like roughing and their finishing and their semi-finishing, and all that stuff can be drastically sped up programming time-wise by utilizing these capabilities. Okay, so if I grab this here, I can, you know, kind of drag it a little bit bigger. I just want to take up a little bit more space there. That way I can go with a slightly bigger radius there. And I'm going to go ahead and put a rad in here and here. And I'm going to go ahead and maybe go with a little bit bigger rad in the back side of this lifter, right? And then once again, I can switch my transparency real quick. So go back so we can kind of see things. And we kind of have so a little bit of my rads modeled up. Now what I'm going to do is I'm going to use a function called intersect keep, right? So we're going to go to the Boolean operations, go to intersect keep, all right? The blank in this case is the lifter because that's what I'm modifying, and the tool is the core block, right? And that makes the lifter match my core block. Now what I'm going to do is do a modified Boolean subtract keep, right? And so what that allowed me to do is my blank now will be my core block because that's what I'm changing, and I pick out my lifter, and it's going to subtract the pocket from my lifter, but not actually remove my lifter, right? So that's it. Just like that, I have that modeled in. I can go ahead and obviously add, say, a chamfer. So let's do 100th chamfer here, and then we switch over to core block and maybe an 80 thou radius. You might want to go bigger with these rads. You can do that too, right? And now we have our rads and stuff we want. And then what I can do is using feature selection, I can pick these rads with minimal clicks. And I can go up here and say, those rads are clearance. And I pick on clearance, and it picks my color, right? So it's really, really easy. And then seal off, same thing. So we make it extremely easy for you to utilize really good standards for your color coding. Of course, the colors are completely up to you. And make sure that if you have multiple designers working on it, that they're all following the same standards, okay? And then what we can do is from here, we're gonna just tell, because this pocket was created later, we just want to tell XMD to kind of check these holes. So we just say regenerate, and it fixes the holes, right? So the proper holes are in the core block, and then the proper holes are in the lifter, right? And as you can see, the dowel's done, the lifter head's done, everything's done, right? So that's it for modeling really quickly. There's to model a lifter, parting line, all that stuff completely can be done in here if you wish. Okay. So the last couple things we want to do is kind of show you how easy it is to get things to the shop floor and to do some kind of quality assurance to make sure that the design is good. So one of the things as a designer that I always fear is water hitting something, right? I've lost sleep in the past over that because I'm worried about that happening. I do not want to end up with a condition where water hits something that I don't want it to hit. So, but if you remember, we did put an ejector pin through a water line on purpose, right? So we have functionality that allows us to check this kind of stuff. So in this case, we're going to check water lines against everything in the stationary half, right? Sorry, in the moving half. And then we're going to go ahead and just say anything within 1/4 inch, let me know, okay? So anything that's closer than 1/4 inch, it's going to let me know about that issue. In this case, that one ejector pin that we placed, right? Because our stuff is so visually appealing and easy to work with, and it's kind of showing you what's happening as you go, you'll notice that this isn't really, it's something that you kind of avoid having these kind of mistakes quite frequently because you can see everything happening so easily. All right, so we go ahead and we move that. I just turn my ejector box on, make sure I didn't put it inside a pillar support or anything. All right, and that's it. So we know our water and everything, all the holes in our core half, we know are not hitting, okay? All right, and I can do a recheck. No further interference exists. So that way, yeah, I moved this pin, but did I accidentally move it into something? Do a recheck. No, I didn't. Okay, everything's good, right? And then, of course, we can check a lot of other things too. So you can check really anything you want to anything, right? So you can check water lines to part, water lines to parting line. And then I have a really cool thing I like to do is I like to also check everything in my ejector box, right? So if I click on ejector box and I say open, right? It populates kind of my standards on how far I want things to be away in my ejector box instead of me having to select all those things. So look at all the things I'm going to check all at once. And I can obviously build on this over time if I want to as well. No interference. So I don't have any ejector screws hitting an ejector pin accidentally, or an ejector pin hitting pillar supports, or an ejector pin or a screw going through a lift hole or anything like that. So I can check all that stuff and make sure it's all happening the way I, what I'm looking for to happen. Make sure I don't have any crash conditions, bad situations. Okay? All right, so what we're going to do now is we're going to go ahead and we're going to show you some other cool functions that we do that allow you to save a lot of time on the shop floor. And some of you may already be doing this manually. We've run into this where customers are manually doing this to help their shop floor. So there's a lot of time being put in. What we want you to do is we want you to not spend time to make things faster shop floor. Because if you have to spend 5 hours to save the shop, say 6 hours, right? That's only an hour savings. So there's really not a there's not a big savings there. So what ends up happening is if the engineering department is super overloaded, they have to skip that phase because they just don't have time for it, and now the shop spends this extra 6 hours anyways. So we need to make it so that it's very, very simple, quick, and also no room for human error, right? So if you're manually figuring out ejector pin lengths, the chance of human error, if you have a lot of ejector pins, it's pretty high. There's a pretty good chance you're going to miss something and have a typo or something. So this is how we kind of resolve that. We do what's called ejector pin chart, right? So we bring up the layout of your job, and this allows you to put in values based on true steel sizes. Okay, so what your shop would do is backfeed you when all the plates come in from Blanchard grinding and stuff. They're going to mic them. That's standard, right? When it comes in the shop, they check sizes and make sure that they're what was ordered. So when they do that, they record those values. Then those values go up to your engineering department, and you can type those values, and you can say, well, the rails actually came in at, this size. It'd be kind of nice if they only came in a thou out. Generally, big things, it's usually a lot more than that. But you can type in all the values, true values that you ended up with. So let's just say retainer plate is, 3 thou out. The ejector plate is 6 thou out. Okay. We go ahead and we can say okay. And what it's going to do is it's going to measure all that stuff and calculate to those extra values that you put in. So what we want to do is for stock, you can add stock to the pin if you would like. So a lot of our customers go to no stock now. They've become so comfortable with this feature now. But you can go ahead and say, like, let's say add 20 thou. And we can put the chart directly in the design if we want. Once again, most of our customers just do an Excel file. So then you run it, but they go, just popped it up on my other screen, and here's the Excel sheet that it developed. Okay, so as you can see, we have all our pin numbers here and the diameters of the pins, right? The actual length, okay? That's the actual length based on the steel values that your shop backfed to you, and then stock, right? So here's the value with if you want to put a little bit of stock on it, okay? And then also we let you know if it's a keyed pin or not. And then here's your XY locations, okay? So a lot of these I placed with utilizing my snap, so you get the numbers are, for most of them are nice, right? And then you got ejector pins and return pins, okay? So and what the pin type is, this also works for core pins and sleeves. So really nice function for sleeves. There's no more going up on height gauges and measuring and trying to figure out what your true sizes are for your sleeves. Now you can run this and your customer can make the sleeves right to size, stick them in and good to go. Right? Or your shop floor, sorry, can make them right to size and you're good to go. So as I said, there's pin numbers here applied. Let's just go ahead and close this. And those numbers get applied on the 2D drawings, okay? So now they can, your shop floor can look at those. Now better yet, I can take those numbers and I can map them down to my retainer plate. And now your shop floor can engrave those values right on the retainer plate. So when the shop floor cuts these, they don't even need a print to figure out where they belong. They have a map right on the steel that tells them where to put them. So once again, make things very, very quick and easy for you with that particular function. Okay, so let's hop over to the material list real quick, show you a couple things about it. So as I mentioned, the material list is automatically filled in, all the values and sizes are. What we do is we leave you the flexibility to add the detailed numbers to every single component yourself, but we do it in a very easy manner, okay? What that allows you to do is sort things in a particular order if you wish. At some places, they only add detailed numbers as they order stuff, so it gives you that flexibility to do that as well. So I'm just going to say, okay, well, here to here, these are manufactured components. I want those to be in there first. Then I want like my push ports, my vent inserts, my lifter rod, let's say next. And then after that, I'd like my hot runner system to be put in there. And then everything else is kind of sorted based on the vendor. So we just go ahead and be okay with that. And that's it. So that is the extent of work that you have for materialist inside XMD. Okay, so just going to show you, we also output this to an Excel for you so you can send it to your purchasing. The Excel, obviously, when you create your template, can match whatever it is you currently do, or you can modify to the standard one, which is what you're seeing here. It's completely up to you how you want to do it. There's your material list, right? So this is the standard material list that we've given to shop floors and to purchasing for really since the beginning of material list. We've always given it like this. One day, though, we kind of had a light bulb go off on our end, and we realized that this material list has very minimal use for the shop floor. Yes, it tells them what they need for components overall, but it doesn't really help them on what components they need for which plate, right? So when it's time to assemble the core block, how many plugs do I really need? How many baffles do I need? How many, jiffy plugs and pipe plugs and all these things? How many do I really need for that particular block? So we solved that issue as well. And what we do is we have a second material list that you can output. It has all the exact same items in it, but it's sorted based on the plate that they belong to, right? So if I open this one up, as you can see, cavity block has 4 guide pins. It has 2 Jiffy plugs. It has 9 pipe plugs. It has 4 socketed cap screws of this particular size, okay? And then, of course, core block, all its components, command plates, its components, and so on, right? So we're doing a couple things here, right? We're solving an issue for the shop floor to make it easier for them for assembly. We have run into customers who actually take time to do something similar to this to help their shop floor, but it's very time consuming, and it's very prone to errors because it's manually done. So once again, we automate it for you to make it quicker, more accurate. And if you're not already doing this for your shop floor, you're adding value-added component to your shop floor that will save a lot of time and make things a lot easier for your shop floor. So that's kind of a quick idea on the material list. Now, another big thing that happens is getting files to the shop floor. Can be a very daunting task, especially when you get into these big files. You know, some of our customers that do like fascias and these great big door panel molds and stuff. They have the amount of components and lifters and everything that they have. It's massive, and they sit there and they output every single one of these components one at a time to the shop floor. It is a massive undertaking. It takes a lot of time. They usually have a really cool naming system for going out to the shop floor too, and so that naming system has to be typed in every time they output. So once again, we can solve that issue, right? So what you can do is, in this case here, I'm just going to switch my main template to match what my design is in right now, and I'm going to go ahead and I'm going to export this particular file. Okay. All right. So automatically, we have file names that are being applied to these, and these are 100% configurable. Okay, so you can make these file name structure as complex or as simplistic as you want. I wanted to kind of show you, how drastic you can get with these file names. And what's cool about what you're going to see here is this gives a lot of information to the shop floor about that component just in the file name alone, right? So job number, detail number out of the material list automatically being applied. What the component is, and this is really cool too, is you can do this a couple different ways. I can make this value be the plate name, or I can create plate codes. And what that allows me to do is teach the software, if somebody calls it a top clamp plate, which is kind of what it goes to as default in XMD anyways, but somebody renames it to cavity clamp plate, you can teach it that in the file name, still use top clamp. Use top clamp even if you see cavity clamp plate, okay, things like that. So this way your file name structure is extremely consistent on the shop floor. Consistency is key, because more consistent things are, the easier it is for your shop floor to find things and utilize things. If I all of a sudden change, if it's currently called top clamp plate, but I change it to be cavity clamp plate, and the shop floor has 40 files to look at in a folder, and they're looking for top clamp plate, but you've renamed it to cavity clamp plate on them, they're wasting time figuring that out, which can be sometimes a time-consuming thing. So we make things very consistent, which makes shop floor much quicker. But I can also create additional drop-down menus if I want to even add more information to this. So for example, we're going to just say this is full finishing, and the 2D, like all the water lines and screws and things like that are all in this. We'll say full 2D, okay? You see too, we do have an FCS option. We didn't use that in this demo. So if you do utilize FCS, be sure to check out one of our videos showcasing the FCS component in XMD. We automate putting in that FCS for you. If you're not sure what FCS is, then you don't use it. All right, so now what we're going to do is tell the software to output all these files individually with those file names, and I can pick whatever file format I want. Okay, and I can also pick multiple file formats. So I can do a step and an IGES, so that maybe the IGES is a backup if something's wrong with the step file, things like that. So I can do that. And I can also output it to a very specific location if I wish. So somewhere on the server, so that the shop floor can grab it. So what you can basically do is, let's say it's the end of the day, you can go ahead and hit export and walk away, right? Oh, you got to select, sorry, didn't select all my plates. You got to pick all the plates you want to export. Now I'm going to go ahead and say export. Okay. Now what it's going to do is it's going to output all those files. It's going to make sure those files have all the same, those specific hole colors are applied. all the holes are subtracted. One thing that we didn't talk about is in our design, our holes are not subtracted. We give that appearance that they are. And that's what allows us to make manipulations so fast, move holes around and stuff, and not have to ever worry about there being an issue, okay? It brings you up to the folder that it put those particular files in. It also lets us know if there's any files that did not export. In this case, the hot runner system did not, because it's the hot runner system and they don't need to output that. So it's just letting me know that it did not. But if it has an issue with pulling a hole for some reason, you got bad geometry or something, an injector pin hole doesn't pull, it'll actually specifically let you know that there's a 3/8 diameter ejector pin that was unable to subtract. And then you're able to fix it. And what we'll do is we'll actually leave you to subtract in the location that it couldn't. And you can manually fix it if you want to get it to the shop floor, and then you can figure out what's going on with your file later if you'd like. So we give you a lot of, really help you with that kind of stuff too. We all know the perils that can happen in CAD geometry, and so we do it. So this is that file, holes all subtracted, and as you can see, color coded based on the hole type, okay? In that export function, if we just hop back to it really quick, there's a lot of other options in there as well. I don't even have to do subtractions. I can leave the solid subtracts floating in there instead. I can also have all the holes be wireframe if I'd like. So it just depends on the software that you're using. We also do another cool thing with angled add circle for angled holes. So this is for our users out there that utilize certain technology, especially for gun drilling, that the way the technology works is it looks for two circles, a starting circle and an end circle. And that's how it does all its drilling procedures and figures out its drilling procedures. And because it's a spot face, we don't have a circle at the starting point. So our customers would have to sit there and draw that circle manually. What we do is we apply the circle automatically. So that's an option you can turn on or off. But that gives them that starting and end circle, so that this way there's the software these softwares that utilize that technology automatically have everything they need in there, and they don't need a somebody to draw that stuff manually or do it themselves on the shop floor. They got 30 spot faces in there and they got to go in there and do it themselves. We save all that time as well. Once again, we're thinking on the design end and the manufacturing end. We're trying to make things faster for everybody. Okay? So that's our demo, showing you some of the key features in XMD. There's several other things that we can do, obviously, with creation of custom components like safety straps and different things like that. Custom assemblies, which allows us to say, for example, place a safety strap that has a screw hole and its storage position hole, all attached, automatically goes in. Your materials is taken care of. So a lot of other cool things we can do, but I wanted to keep this under an hour, so I kept it. I kind of showed some of the minimal things that I needed to. We have other videos available that you can look at, placement of some of those things, utilizing the Dyna handle, which allows you to do all kinds of cool things for placement as well. Be sure to look up those other videos on our YouTube channel to see how those work. And go ahead and get in contact with us. We'd love to do another demo for you, or get you set up with some training and get you going and help you achieve your mold designs much, much faster, more accurately, get it to your shop floor quicker, save on overtime, and be able to bring in more capacity all at the same time. Thanks for your time.
Thanks, Sean. That was really well done, as usual. You've shown very well how we automate and simplify the mold design process. Now, before we sign off, let's answer a couple questions that have come in. If you type your questions in the webinar, as Adam mentioned earlier, or click the question mark symbol at the top of your mobile panel, you can type a question to us. Now, we have a couple that have come in as mentioned. This first one is becoming very popular across Europe and North America. You did touch on it in your demo here. You mentioned that you have a clamping tool. Can you show that?
Oh, for the FCS. Yeah, let's go. Let's switch back to my screen there, Adam. Okay, so yeah, let's quickly kind of show that. So we do have an FCS tool in there for putting in your holes that help automate it. There's a really cool configuration, so you can configure exactly what your pallet is like. You can even configure what machines on your floor have which pallets, and how many of all the different standoff tooling and stuff that you have. So there's a lot of options you can do there. So I'm going to go ahead and just add FCS, let's just say to the core block. And it's really just right clicking on whichever plate or plates. You can do multiple plates at once as well. And you're just going to say add FCS. And it's going to automatically look, and it's going to do its best to try to avoid any existing holes. So that's also configurable too on what types of things you want it to kind of make as a kind of a preference in order of what's most important to you. So then you just kind of pick which ones you want to go with and which ones you do or don't want. And let's just say we're good with everything that's in there. We'll just go ahead and just accept it. And it'll put them in. It'll automatically put any see here, it's putting in any spot faces that are needed or anything like that. I can also switch to certain views, and I can make changes, so I can grab and maybe move a pattern around if I want, things like that. So it's really, really easy. And then you just hit enter again, and they get placed in there. And once again, just like everything else, you can see they're all color coded. So these are metric holes, so they have very specific color. Once again, whatever colors you want to input there. You see the spot faces are in there for the proper flats and everything for all 40 mil stacking and things like that. So yeah, putting FCS, we make it much, much easier. It's not a bunch of manual stuff, and it's set up specific to whatever your customer or your particular application is.
Yeah, like you mentioned, the pocketing and the collision avoidance works really, really well. And we also, I believe you mentioned, we have this ability to configure this so that when you first start your design, it'll populate on the main blocks or plates, however you have it configured, right from the very beginning of the design. So it's not even an operation to add it in later. It actually can be in place right from the very beginning. So just going back to the questions, we do have another one, someone being kind of funny. Where are your shipping straps with a smiley face? But I think you did mention that at the end too, but maybe you can show how we would handle that.
Yes, we got what's called custom assemblies, we call them. So you can create your own custom assemblies for things, your own things that aren't maybe built into XMD that are more kind of your own standards, you can generate very easily as well. So these things called custom assemblies, and then we have a thing called dyna handle that makes it very, very easy to place them, move them around, orientate them, and things like that. So let's go ahead and let's put one in. So I'm going to go ahead and add a custom assembly. And so if I go to, so you can make your own brands. This is like catalogs that you can kind of create for yourself, right? So if I go ahead and pick whichever safety strap I want to use, and in this case a yellow one, so you can have different colors, you can have whatever you want to do there. And what it's going to do is, because when I created this custom assembly way back when, I made it so that it automatically looks for the side of the block, so I can kind of have it do that automatically. And then I can just use my dyna handle to drag it to wherever I want. And then what I can also do after I've placed it is I can make modifications to the custom assembly. So for example, I have a storage position hole you can see here. So if I want to move that particular hole, I can use our dyna handle to do that. So I say click on that hole. And what I do is say, let's reposition the base point, because base point automatically goes to the center of the hole, but you can change that base point to say here, and I'll shut off assembly so that I'm only affecting the hole. So I reposition that here. And then what I can do from there is I can take it and I can rotate it to wherever I want. So I can kind of like manipulate just parts of the assembly if I want, or I can manipulate the whole assembly. So maybe I want it just the other way. So it's really easy. You obviously create custom assemblies for wear plates, your hydraulic cylinders with all the fittings on it, your water manifolds with all the fittings on it, things like that. So you can very easily and quickly place that stuff in.
So I think with that, we've probably kept everybody long enough for today. Thank you to our partners at Kupatech for hosting this webinar. And most importantly, to all of you that have signed on and taken the time from your day to watch, we greatly appreciate all of you. Contact us. We will be here to help with any other XMD mold design questions. So have a great day, everybody.
And just so you know, anybody else with questions, there's some more questions, we will get back to you via email on your questions.
Thank you.
Thank you.